Hello students, I welcome you to this session of refrigeration and air conditioning. In this lecture, we will discuss the definition of psychrometrics, and we will also learn what are the different important psychrometric properties in air conditioning. So let us first understand the meaning of air conditioning. Now, air conditioning is the process of treating the inside air in the room so as to control the temperature, humidity, cleanliness and distribution. Okay, suppose the temperature inside is more, as you can see in the summer condition, and outside is also the temperature is very high. In summer we have the outside condition as 45 degrees Celsius as the temperature. Okay, and inside also sometimes the temperature reaches up to 30 degrees Celsius to 35 degrees Celsius. Okay, so this condition or this temperature is required to be bring down so that the human beings which are sitting inside the room may feel comfortable. Similarly, the humidity, if the moisture content in the outside air is high, then the air conditioner will also help to maintain the humidity content inside the room, sometimes which becomes high due to the high moisture content in the outside air. Okay, and any dust, dirt or any pollutant which is being released from inside of the room is also controlled by the process of air conditioning. And finally, distribution. Okay, so the air should reach each and every person which is sitting inside a particular room. So that's why the distribution of air to each person who is sitting inside the room is necessary. Now, as far as psychrometry is concerned, it is the branch of science which deals with the study of behavior of moist air. Okay, or it is the study of the thermodynamic properties of air and water vapor mixture, important from air conditioning point of view again. Okay, so air which is generally present inside the room consists of the dry air plus water content in it. So if we combine both of them, that is the dry air and the moisture, then the air is called as the moisture, and the study of this moisture is called as the psychrometry. As I told in the previous slide about the moisture, so let us understand the more composition of the moisture. Okay, so atmospheric air, as you can see, which is present in the outside, consists of both the mixture of permanent gas, it consists of water vapor, and also it consists of dust particle, fumes or any other pollutant. Okay, so we have the permanent gases as nitrogen, oxygen, argon, carbon dioxide, etc. And then it also has some amount of water vapor in it. Okay, and apart from that we have the pollutant or dust particle, etc. So all these combined lead to the atmospheric air. Okay, now dust particles or pollutants which are present inside the room are to be first filtered out. Okay, so this process is called as the filtration, and you must have seen the filter in your window air conditioner or split air conditioner where the dust and dirt particles are removed. Okay, so it is the filter present in the air conditioner is in the form of fine wire mesh. Okay, so after the filtration we are left with mixture of permanent gases whose composition is fixed, and then we have the water vapor which is present in the air. So combination of these permanent gases and water vapor is called as the moist air, and now it is available for different psychrometric processes. Okay, now let us first understand the composition of the atmospheric air. You must have read earlier also that the nitrogen is the most abundant gas in the atmosphere, that is, it occupies the largest share in the atmospheric air. So as you can see over here, we have the molecular weight of the different gases which are mainly present in atmosphere. So oxygen having a molecular weight of 32, and by volume the amount of oxygen in percentage it is around 21%. Okay. Similarly, nitrogen we have 28 as the molecular weight, and it is present in the atmosphere around 78.1%. Argon having a molecular weight of 39.944, and percentage by volume is around 0.0093. Okay, and carbon dioxide finally, it is having the molecular weight of 44 and having a percentage by volume equal to 0.3% in the atmosphere. Okay, so molecular mass of dry air. Okay, if you consider the presence of all these four main components, because air also contains, apart from these four components, other gases too, but their amount is so small that it can be neglected. So molecular mass of dry air, when we consider these four components, become 28.966. Okay, and gas constant of dry air, which is represented by Ra, is taken as 287 joule per kg Kelvin. Okay. Similarly, molecular mass of water vapor, Mv, is equal to 18.016, whereas gas constant of water vapor, it is Rv equal to 461 joule per kg Kelvin. Now it is important to learn all these four values because it will be involved in various calculations of air conditioning. Okay, and the amount of water vapor which is present in the air at a particular location depends upon the pressure and temperature of the mixture. Okay, when I talk of the mixture, it means the dry air plus water vapor. Okay, and at low pressures, especially, the dry air and water vapor both will behave like a perfect gas. So it is assumed that below 3 atmospheric pressure, both dry air and water vapor behave like an perfect gas, and the relation of the ideal gas will be used for deriving the various relations. Okay, now in this slide we will discuss the meaning of saturated air and unsaturated air. Okay, so saturated air is defined as that air which has the maximum content of water vapor in it, or maximum amount of water vapor in it at a given pressure and temperature at a given location. Okay, so when you cannot add any, or you are not able to add any moisture to the air, then it is understood that the air has the maximum amount of moisture in it, and at value of relative humidity equal to 100%, we are not able to add more moisture in the air. Okay, so this is, you can say, also a measure of the relative humidity of the air. Okay, and now coming to the unsaturated air, it is defined as that moisture in which the amount of water vapor is less than its maximum value at a given temperature and pressure. That is, if you are able to add more moisture to the air, then that air will be called as the unsaturated air at that location for a given temperature and pressure. Okay. Now, the next point is also very important to understand. It says that the partial pressure of water vapor is low. Okay, so the total atmospheric pressure is consisting of the pressure due to dry air plus pressure due to water vapor. So this pressure is called as the partial pressure exerted by the dry air part and partial pressure exerted by the water vapor part. Okay, so if you consider the partial pressure of the water alone, then you will find that at a given temperature the water exists in a superheated condition. Okay, so for example, the outside air temperature is 40 degrees Celsius. Okay, so at this 40 degrees Celsius, if you calculate the partial pressure of water vapor, okay, and find the corresponding saturation temperature, okay, you will find that the saturation temperature is very low, whereas the temperature which I have just told is 40 degrees Celsius. Okay, so that's why the water will be in the superheated condition and it will behave like a perfect gas. Okay, next, more about the psychrometry I will discuss in the next lecture. Thank you.